Welcome back for another episode of the 5G Guys. I'm Wayne Smith, and I'm joined by my co-host, Dan McBall.
Hey, everyone. Thanks, and welcome back. Thanks for listening. Another episode of 5G Guys. Before I introduce our guest and dive into today's topic, Wayne and I are excited to announce a new offering for our listeners. We found that many of our listeners have follow-up questions or suggestions for future show topics. So what we've decided we're going to do is ask you to go to 5gguys.com and connect with us. And we're offering anyone with show ideas or questions for a free consultation with Wayne and I. So if you got a question or problem you're trying to figure out, show ideas, we'll do a free hour with you. We'll record it and possibly have you be on one of our future episodes. So go to 5gguys.com, submit your questions, and maybe you'll be on a future episode. So now I'll get to today's episode. I'm excited to introduce our guest today, Pete Bernard. Pete is an innovator at Microsoft, where he drives Microsoft's strategy for the intersection of 5G, IoT, and AI. Now, don't worry if those acronyms are already having you spinning. Just sit down, have a drink. We'll explain what they mean. And Pete will help us break all that down and make sense of it. But this sort of innovation isn't new stuff. Since getting his degree in computer science from Boston University, go Terriers, I think?
Yeah.
Terriers, all right. Pete's been driving product disruption and ecosystem partnerships into the intelligent edge, telecom, and services arena for years in the Silicon Valley and at Microsoft. And he also happens to be his own host of his own Microsoft podcast, the IoT Unicorn. So, Pete, thanks for joining us. Excited to talk about 5G, AI, IoT, and edge computing.
Yeah, great to be here. Great to be here, Dan and Wayne. Appreciate it. I know, Dan, we actually met, I think you reminded me, a few years ago, back in the old days, pre-COVID days, when we had face-to-face meetings. But I think I spoke at the ISC Western Wireless event or something, and it was like a lot of the telco infrastructure folks, and I met a lot of cool folks, including yourself and your colleagues. And so that was pretty cool. So it's great to be back in touch, and I've listened to a bunch of your episodes, really educational. So hopefully I can add to that in some small way.
You bet. I have no doubt that you can. So I guess before we dive into the weeds, I've been known for having some kind of corny analogies to explain technology, but I thought maybe we could try a couple out on edge computing and AI for our listeners. Maybe you can kind of give me some feedback if that works, if it's a good way to help it break it down for the layman. So when I think about edge computing, the analogy that comes to mind for me is if I think about the old cliche of the left hand doesn't know what the right hand's doing, right? And we need our brain to sort of coordinate between our left hand and our right hand. And in a cellular network, or really any telecom network, that's traditionally how networks have been, right? There's a core brain, whether it's a switch center or a data center, that's doing all the processing and decision-making, and then just telling all the network elements, cell sites, cell towers, whatever the case might be, access points. Think of those as our left hands and our right hands, and tells them how to coordinate with each other, how to do things together. But when we start talking about what's coming out now with edge computing and 5G, that's almost like our left hand having its own brain and our right hand having its own brain. Mm-hmm. And they can almost communicate directly to each other with our brain in the middle, not slowing things down. Right. Does that analogy work, you think? Is that a good way to kind of explain edge computing?
I think that's a good way of thinking about it. I mean, basically, in the old days of embedded computing or IoT, like we used to have pretty dumb sort of sensors and endpoints out there. Maybe think of a moisture sensor or some sort of sensor out there, and it would send information up to the cloud. And that was kind of, the basics. And then we got kind of two-way communication, right? So then the cloud and the edge could sort of talk to each other, and you could send information from the cloud to the edge as well as from the edge to the cloud. And now, the edge itself is adding more compute power, the semiconductors on the edge, that everything from your doorbell to your car. Actually, I read that there's about $500 worth of semiconductors in today's cars, as opposed to like $80 that used to be. And so now the edge is becoming, having quite a bit of compute power in and of itself, right? So these endpoints, millions and billions of endpoints are able to compute and, do things on their own without having to talk to the cloud or be reliant on other parts of the network. And so that's kind of the essence of when people say edge. Edge is also a relative term. So it sort of depends on where you're standing, where the edge is, right? And sometimes the edge is that moisture sensor out in the field in an agricultural kind of deployment, or sometimes the edge is the edge of an AT&T's cellular network, the edge of their data center in the metro, or edge could be a server, on a manufacturing floor. So wherever sort of the workloads are the farthest out is typically where the edge is. But even in that, you have sort of a tiered system going back up to the cloud. So it can get a little complicated, but at the end of the day, what it really means is that all these compute points are getting more and more horsepower, and they can do more, and they can do more independently. So that means you have a lot more options and possibilities of hooking this stuff up.
Right. Yeah, and as a matter of fact, a good example of that I heard from somebody I was talking to the other day is a smaller wireless internet service provider that's deploying wireless 5G networks for internet access at your house. Mm-hmm. And they've got some cool stuff going on where they're pushing content to the edge, where their edge is basically the device that's in your house that's serving streaming video to your TV and to your phone, right, for example. Well, that Netflix episode actually is not going to be residing on the cloud now. It's going to be residing on that device in your home. Mm-hmm. And so now you're not using up the network at all when you're streaming. It's just downloading what it thinks you want, using things like AI, which we'll get to next, to figure out what it thinks you like, right?
Yeah. There's a lot of the reason why people use edge technology could be for that, because they want to be really smart about how they use the network and when they use the network. Also, it could be for privacy reasons. Maybe they want to keep the data local and on-prem, like imagine AI vision cameras. You want to keep all that sort of secure on-prem and not back up into a cloud or a public cloud, or just low latency, right? So you want to be able to do things in, single millisecond latency on a manufacturing floor for worker safety, things like that. You don't want to be traveling all the way back up, through the network, all the way back up to some cloud and back down again to be able to do those sorts of things. There's a lot of good reasons to use it. And I think what we're seeing is customers are getting really creative on how to use the tech.
For those that don't know what latency means, think of latency not as speed, but latency is how quickly you're asking for something to be done, how quickly the network responds to what you're asking for, right? Exactly. So my analogy of a supercar being a 5G handset, you hit the gas and it freaking goes right away, right? It responds immediately. That's low latency. So
yes, exactly. And I've heard, I had the guest on my show actually from Qualcomm who was saying the single flap of a bumblebee's wings is about 5 milliseconds.
Oh, okay.
Wow. So that gives you an idea. It's pretty fast.
Hey, real quick, a quick word of thanks to today's sponsor, Vertex Innovations. But for over 17 years, Vertex has been building the nation's wireless and broadband networks, providing project management, network engineering, and construction oversight are just some of the ways Vertex helps their clients. So if you're looking for more of a partner to help you with your wireless network designs, construction, implementation, or operations, reach out to Vertex. You can find them at vertex-us.com. That's VERTEX-US.com.
Yeah, Pete, one of the things you mentioned is workloads.
Yeah.
And so what do you give us a definition of what a workload is? Because I think in a case study, what is that? What do you mean by that?
Yeah. So, workloads, and that's another one of those kind of industry terms, but it's basically, it's a set of code that needs to be run. And that could be a set of code that's, doing some level of compute or analysis or some sort of compute. So that workload can run that work. Right now I'm running on my Surface Book, my beautiful Surface Book, and I'm running a bunch of workloads on it to, capture my voice and to display on the screen and to do all sorts of things. But in some of these IoT or edge deployments, those workloads may be running on the cloud, on the public cloud, like on Azure, or those workloads could be running on the camera itself in the convenience store, or it could be running on a gateway box in the lunchroom of the convenience store. So those workloads, what's really exciting about that world is that you're now kind of distributing workloads right between the edge and the cloud. And on the plus side, it's a lot of great flexibility for customers, especially commercial customers, to design some really great solutions. I guess on the downside, it makes things, kind of infinitely more complicated. So that's the negative.
So there was a couple other acronyms we threw out along the way here. Yep. We talked about IoT and you touched on what IoT is, Internet of Things. Mm-hmm. And the best way I describe that to people is it's not individuals. It's not you and I using the network. It's a Ring doorbell. It's that sensor in a factory. And by last I heard, and maybe you've got more recent numbers, I've heard there's something like 10 times more IoT devices in the world right now than there are human beings. That may not be the right number, but it's huge, right?
I probably have 50 IoT things right here in my office, and it's just me. So there's a 50-to-1 ratio right there. But I wouldn't be surprised. Yeah, I mean, everything, and so many things are internet connected today. And in the consumer world, right, you've got doorbells and you've got, your Bluetooth scale and your Fitbit and your phones and all kinds of things. And in your car, so many things that are happening in your car that are connected to the cloud too. So it's, that's one of the benefits of 5G, by the way, is the high density capabilities of 5G is the ability to handle, billions of connections and much higher density for a given tower and deployment than traditional like 4G, which is pretty exciting for us because we can then, a farm can outfit, lots of connected sensors and robots and other detection systems, in a huge, multi-acre deployment using 5G, or you could do that at an airport or, shipping containers, all kinds of things. And they can all communicate on the network without any, issues around latency or other confusion in the network.
All right, so let's do one more. Let's talk about AI. So artificial intelligence, right? I'll let you take this one. How would you break down AI for a layman? And is it the Terminator cyborg that the world's gonna be taken over by robots, or
Right? Yeah, not yet. So that's good news. But no, AI has been around forever. Not forever, but decades. And in a computer science world, they've been experimenting with AI for a long time. What's happened probably over the last decade is that the amount of compute power, and going back to semiconductors and things like that, have gotten so significant that you're able to run these AI models. You're able to train models, AI models, which is just code, to recognize things and to be able to do things. And so there is, because of the compute and the storage and the network capabilities, you're able to run artificial intelligence in much more profound ways than used to be. One simple example of AI would be, when you go to Netflix and you watch a whole bunch of mobster shows or whatever, they recommend a mobster show. Hey, you might like this mobster show. That actually is a form of AI, very simple, machine learning type of AI. More advanced AI would be, well, I have a camera pointed to my production line and it's visually inspecting, equipment that's being manufactured and it's looking for defects. And so I've trained it to know what a good part looks like, and I've trained it to know what a bad part looks like, and it can do all kinds of on the fly, anomaly detection through visual AI. So AI is really just that ability to kind of decision making based on training and based on input. And now we have the compute horsepower and other infrastructure horsepower to do it at a much more significant level. Not quite Terminator yet.
Right. The analogy I've given people is, when I went to engineering school and people ask, what did you learn in engineering school that you use in your career? And I said, well, I learned how to learn. And that's really what we're doing, right? We're teaching these compute platforms how to learn, and then they go off and learn on their own without the old way of them just doing what we tell them to do.
Right. Yeah, there's training and then there's inferencing. And that's kind of another little breakdown in terms of workloads, going back to that term. How do you train the models to recognize, license plate recognition? That's a big one in parking lots and things like that. Or how many, customers are where in the store at certain times of the day and looking at end caps and things like that. So you're training using lots of data, hundreds of thousands of images. And then there's inferencing, which is now that you have the model, you want to run the model on some piece of equipment to then, recognize license plate. So it's taking the model and it's recognizing it. So that's a little bit less horsepower in that kind of workload. But yeah, no, the AI, if you start combining some of these technologies together, things like 5G, which I'm sure you're familiar with, and AI and edge, you kind of get this really interesting Venn diagram overlap, right? And that piece in the middle is pretty transformative stuff. And that's what we're seeing with a lot of our customers working with Microsoft on, like, how do we accelerate our digital transformation with this kind of now interesting new combination of really fundamental technology.
Yeah, wow. A part of that, what you need to make AI work is a lot of data, correct? Yeah. The more data, the better the AI. Is that
exactly? You get the model is trained. The more data you can feed into it, the better the model is trained to be, the more accurate it's going to be.
Okay. And 5G is that pipe in order to get your data from one place to another fast enough, or is that a true assumption or no?
Yeah, I would say, there's getting back to sort of training and inferencing, a lot of model training is happening on the cloud today. So you're using some pretty big compute horsepower to do your training. Like you would not do a lot of training on your local PC. It would take a long time, so really what you want to leverage your Azure or your AWS or GCP or something like that to do your training, and you're feeding in a ton of data. a ton of data. We have a partner that does a lot of lumber stuff. And so they can recognize, discrepancies in the lumber pattern or whatever. And so they've got, millions of images of lumber that they put into the cloud and crunch through and create an AI model to do that. So typically you're not using 5G for the ingress of the data for training. You're more of, using 5G to communicate, with those cameras, over the network to do the inferencing maybe of the actual real world using those AI models, if that makes sense.
Yeah. So 5G is basically allowing us to access that AI after it's been trained and take advantage of it.
Yeah. And so, one of the interesting things about it is if you have AI vision and, you're doing over 5G, you can do some interesting things where you can recognize, instead of streaming all the data back to the network, back up to the cloud, which could be quite expensive. You could actually do a lot of inferencing on the edge and actually use very little data and use, what we call LPWA or low power wireless access, and use very little data and only send sort of what's called the metadata back to the cloud for action. And to say, we have, the camera has now recognized that someone has fallen on the floor. And then you can actually start streaming the data because of that action back to the cloud, as opposed to streaming all the data. So, when you start combining things like the 5G and edge and AI, you can do some really smart things and use the network in a much smarter way, I think, than if you had to just pump data up to the cloud and look at it later, right? It can all happen very real time.
Yeah, I know a good application for AI, specifically in a cellular network, that actually the idea was born 15, 20 years ago. It just is taken until now to have the compute power and the edge technology to enable it. Is network operators now can have cell sites that can self-optimize, and they can say, hey, I know where traffic's located, and I know, hey, this cell site's overloaded and it can't handle all the traffic, but the cell site next door can handle more. So I'll use AI to shed traffic off of this cell site onto that cell site, and the network's doing it on its own without someone telling it to do it. In the past, we'd have to send a technician out there, climb the tower, physically, mechanically down tilt the antenna so that the footprint got smaller so the site next to it would take it. And now that's all happening through AI.
Yeah. And so, we have a lot of customers, including telcos. We've made some announcements with AT&T and BT recently where they're using Azure ML and they're using a lot of Azure services, big cloud services to optimize their networks and move those workload word again, onto Azure and onto the public cloud to get a lot more kind of scalability. And so, we're seeing AI applied back in the network itself, like you said, for like routing and traffic optimization. And then, my area is more of like outside the data center where we're using AI and edge for some of these interesting kind of scenarios as well. But yeah, it seems like on a daily basis, and I guess that's one of the benefits of working at Microsoft. We work with so many Fortune 500 customers that come to us and they have some really kind of gnarly problems that they're trying to solve. And so part of what my team does is help them think about how they could use 5G and edge AI to solve some of those problems. So it's kind of a never-ending list of interesting challenges, I would say.
Do you have a great case study that you can kind of share with the listeners about in practical application? Not customer wise, but more or less, just the application.
Sure.
Yeah.
One of the interesting things that's emerging, originally hadn't thought of this. I mean, when they think about like 5G and edge AI, you think about like deploy anywhere, right? So you can peel and stick a camera and it can be in a moving vehicle or it could be out in the middle of a field and whatever. So that's pretty straightforward. So we had that. And then we also heard a lot about deployment costs and smart cities or critical infrastructure deployments. If you can have a device out there that doesn't require any cabling, for example, if it can be self-powered and 5G connected, then you're reducing your deployment cost by like 90%, right? Because you don't have to, jackhammer the sidewalk and lay new cable and stuff like that. So that was interesting. And then the third thing that was kind of a surprise was we heard from a lot of retailers and other folks with storefronts and things that they did not want to have a lot of heavy edge equipment in their facility. I don't know if you've ever encountered in real life like a server blade like you would see in a data center. When they run, they kind of like sound like a hive of bees. And so it's not the kind of thing you would want to stick in your lunchroom and run your store off of. So that we had a lot of customers saying, hey, can I use 5G? Can I have these servers co-located somewhere else, a few miles away? And I'll use 5G to go from like cameras in my store to this heavy edge equipment, like, a few blocks away or a few miles away. And maybe I can share that compute across multiple stores in the neighborhood. And so that was a really neat way of leveraging like a low latency 5G connection and also getting the benefit of not having a bunch of heavy edge equipment in your store, which by the way is kind of like someone could steal it, someone can kick the plug out. It also sounds like a hive of bees, so it's not good. So that was kind of a neat scenario that we hadn't really thought of, but our customers came to us and were like, that's, that would be fantastic if we could do that. So we're now working with a lot of our telco partners and hardware partners to do just that, which is pretty cool.
Yeah, well, and I think the other thing that, like that scenario you described, what it does is it creates this what's called democratization of technology, right? Mm-hmm. It makes this advanced technology more accessible to the larger world, where prior to these convergences of technologies, it took a lot of money and capital and resources to take advantage of technology. Now, with all of this, like you said, I don't have to have large compute hardware for me to do that. I can have a service where I'm paying a marginal amount, maybe monthly, to have access to that compute power without having to buy it. I think a good example that's happening right now is mobile 5G gaming. And this will be something, this is an area where 5G is really going to start benefiting the consumer. Is you have almost, I think I heard you've got more gamers now on mobile devices than you have on, Xboxes and PlayStations and PCs, because they can now leverage 5G edge computing to do gaming from their phone or from their Chromebook or from whatever, Right. And so it's now people that couldn't afford to have a gaming platform now can use 5G, and they don't have to have internet service at their house anymore either, by the way. It's a mobile 5G service.
Yeah. I think we're seeing a lot of folks, and I think on the business world, what that means is like small business, other startups and stuff can, like you said, in the old days, you'd have to drop in half a dozen different boxes into the back room and have someone know how to configure them and run them and all that good stuff and buy all this equipment. And now, you can sort of get all that stuff on a monthly basis and not install pretty much anything except the edge pieces. And, that then, like you mentioned, also gaming. And, we have lots of folks with our Xbox service using that via the cloud as well. And, that means you just kind of play anywhere, right? You can certainly would want you to buy an Xbox, and we should all buy Xboxes and sit at home and play Xbox. But, can't always sit at home and play Xbox. Sometimes you're on the bus or, you're somewhere where you want to use, remotely. So, being able to extend that out and have that horsepower in the cloud and leverage a high performance network is a fantastic thing.
Yeah, I read an article before using 5G for gaming. Mobile gamers 1 out of 3 times ended their gaming session because latency made the game impossible to play. Right? You're a first shooter gaming, kind of thing, and you got shot because you couldn't pull the trigger on the game fast enough. So now with 5G, now all of a sudden that goes away. That's where that latency improvement comes in. It responds faster, right?
Yeah. And also, a lot of these telcos are reaching a lot of capacity, frankly. There's just so many people with phones and other equipment connected to these networks that it makes some of these kind of high performance experiences not really work too well unless you're on 5G. So it's getting back to that kind of high density benefit is that, you can get a lot of these things connected at the same time over a single tower, a lot more of them over a single tower than you used to be able to do.
Got it. So I think there's one other term that I realized we've been throwing around in our talk today that I want to make sure we clarify for folks, and it may actually be a good clarification for Wayne and I as well.
Sure.
What's the cloud?
The cloud, yes. I remember actually a funny story. So I have 3 kids and they've all grown up here. We've been up here in Bellevue, Washington for like 16 years. And I remember sitting around the dinner table and my daughter, who was, I don't know, she was in grade school or something. She asked about the cloud and she was like, she didn't understand how the computers could be in the cloud. Like that didn't make any sense to her, like up in the sky, and so first rule number 1 is it's actually not in a cloud. It's actually on the ground. So, and they're in these huge data centers. And so, you can think of the cloud, a big collection of compute in these huge data centers. And these data centers, if you go on search on Microsoft, I think on YouTube, we have some cool video tours of some of these data centers. And we have something like 50 or 60 of them around the world. And they're just like, a dozen football fields of concrete and cabling and just racks and racks of servers. And, each one of those serves a different part of the world. And that's what is collectively known as the cloud. And so, we have Azure from Microsoft, there's AWS, there's, Google has a cloud, Oracle, IBM. Azure is a huge one, I think the biggest. And it's just a collection of compute resources that you as a developer would pay for on a as-use basis, right? So you're based on how many VMs you want and what kind of services you want, you pay as you use it instead of paying for hardware that you would install locally. And so that's what, when people say the cloud, that's effectively what they mean.
Perfect. Yeah. So before the quote unquote cloud, companies had huge data closets with their own servers, which you
Hmm.
called earlier on-premise
Yes.
computing,
On-prem, yes.
right? And so cloud allowed them to no longer have to fill a closet with a bunch of servers.
Yeah, and and we still there's a lot of hybrid stuff going on, which makes a lot of sense too. So you have some compute on-prem, but not a full data center. Actually, when I was in school back in Boston, I had a summer job at Prime Computer, who's long since gone out of business. And truth be told, my cousin worked there. So he got me a job for the summer. And, one of the benefits, and I love Boston, but sometimes in the summer, it gets really the benefit of working at Prime Computer in the summer was that the data center was super air conditioned. And so I would spend all my time there in this beautiful air conditioned room and at like 64 degrees or something like that. But yeah, you had to, use a ton of power and resources to cool these machines that ran at a fraction of the compute, right, in these big data centers. And they're still around. And, we're helping a lot of customers basically decommission that stuff and get to a much more energy efficient, more carbon neutral footprint. We use a lot of hydro and a lot of data centers for Azure, a lot more efficient use of power and a lot more elastic use of the resources. So, as your business grows or as your need grows, you just get more compute, click on the screen as opposed to actually plugging stuff in.
No, I think a question that came up in my search, by having you as a guest is that everyone's asking, why is Microsoft getting into 5G as a long-term plan?
Yeah.
Do you want to elaborate on that?
Sure.
It's.
We have, if you think about it, we have a lot of different businesses. Obviously, the Windows business, Xbox business we talked about, a lot of the Microsoft 365 business. All this stuff has to kind of connect over a network, right? The age of the disconnected worker, with their laptop that doesn't connect to anything is kind of over. So, so we have to be connected. And so, high performance networks is a real strategic thing for us. If you think about how did the world change back in 99 and 2000 when Wi-Fi became mainstream, right? All of a sudden, you could take your laptop anywhere. You could take it to your meeting room and check your email during the meeting. You can go to Starbucks and work there. So it was kind of a huge change for workers around the world. And that affected us in terms of how we had Office and Windows and things like that. And I think we think 5G is kind of similar. It's one of those once in a couple of decade transformative technologies that will impact how people work, how people play. We acquired Metaswitch and Affirmed past year or two, fantastic companies. Combine them with Azure networking. We have a group called Azure for Operators. And I mentioned the announcements we had with AT&T and BT recently, really leaning in and helping them move their workloads onto Azure, digitally transform their networks and their businesses. So it's affecting not only our big customers in terms of their own digital transformation, but just everyday folks that are trying to get stuff done. If they can do it over 5G and some of the Microsoft products that we have, then everything will just work faster, better, and with the edge AI combination, now we're, creating some new capabilities that just weren't possible before without 5G. So that's really exciting. And now we get, energy companies and transportation companies, healthcare companies are all like, wow, I can do a private 5G network here. I can have we have someone who's working on a 5G network on a train car that can roll out and, be anywhere and, on a construction site. And all of a sudden there's like 5G network there. So it's really a big enabler for lots of businesses and lots of customers that we have.
Awesome. Go ahead, Dan. What did you have?
Well, all I was going to say is maybe, Pete, you can get us a link to that YouTube video. We'll put it in the show notes for our listeners on the website. Then they can kind of see what the Azure cloud looks like.
Yeah, there you go. Yeah, it's pretty impressive stuff. And there's thousands of people that plan that stuff and run that stuff. And it's really impressive.
Yeah, definitely. Thanks for joining us. Super fascinating. You're touching on things that'll, to your point, where it'll transform the future. And thanks for sharing your wisdom.
Yeah, no problem. And I would also suggest if anyone's interested in edge AI, we actually have a product called Azure Percept that we introduced back in March. And if you go to https://get Azure Percept, you can get a dev kit there. It's pretty cool. Within kind of about 30 minutes, you can plug it in and start doing AI vision, and you can do some audio, and you can do all kinds of things. It comes with a lot of AI models built in. So if you want to kind of experiment with edge AI yourself, that's a great way to kind of get into it. And you can show it to your boss, get promoted, be a hero, kind of cool thing. But it's pretty cool. So Azure Percept is definitely something that people can get hands on after the show maybe and experiment a little bit.
Awesome. We'll drop that in the show notes as well for everyone. So go check that out. So yeah, thanks again, Pete. And is there any other ways people can connect with you personally or with other things that are going on at Microsoft?
Yeah, well, I'm on Twitter. Digital Dad is my handle. So you can follow me there, and pretty regular contributor to that whole situation. And then I'm on LinkedIn as well. You can reach me there. So Pete Bernard. And yeah, look forward to more exciting things coming down the pike.
Likewise. Thanks for joining us. And thanks again to everyone for listening. Remember to subscribe or follow the show. Go to 5gguys.com to engage more with us. We definitely look forward to everyone taking advantage of our offer for a free consultation. So give us your show ideas or questions you want to have solved. When I'll give you a free consultation and maybe make it a future episode. So until next time, thanks for joining.
Thanks, everybody.
Thanks for listening to the 5G Guys. For more resources and to connect with Dan and Wayne, check out their website at 5gguys.com. If you enjoyed this episode, be sure to hit that follow button and share this episode with your friends and family.